there, Mrs. Lindquist here. So today we're going to talk about converting between radians and degrees. When we looked at our circle, we saw that 180 degrees, which is half of our circle, was pi radians. So to convert from degrees to radians, we're going to multiply by the ratio pi radians over 180 degrees. And to convert from radians to degrees, we're going to multiply by the reciprocal of that, which is 180 degrees divided by pi radians. So example 2 says, write each degree measure in radians. Express the answer in terms of pi. So if we have 85 degrees, and we're going to kind of set this up like a dimensional analysis problem. So this should look similar to chemistry when you're converting between units. So if we have degrees and we want degrees to cancel out, we would also have to have degrees on the bottom, which is why 180 degrees is going to go on the bottom, which is equivalent to pi radians. So what we're going to notice here is that the degrees cancels out. So we're going to be left with 85 pi divided by 180. We can reduce this by dividing by a factor of 5. Gives us 17 pi divided by 36. So that is our radian measure exactly. That's the arc length for 85 degrees. Okay, so go ahead and try out example B. Pause the video and then we will come back and talk about it. Okay, so we should be multiplying by pi radians over 180 degrees. Again, you always want, if you want to cancel out degrees, you're going to want to have degrees in your numerator and your denominator. So this is going to give us negative 45 pi over 180. And we can actually reduce by a factor of 45. So this will be equivalent to negative pi over 4. So negative 45 degrees is a negative quarter pi. And that is one of our exact values on our unit circle. Okay, so example 3, it says write each radian measure in degrees. Round to the nearest degree if necessary. So we have pi divided by 2 radians. I'm just going to draw my line out here. And so if we want to cancel out radians, we're going to want to put pi radians on the bottom and 180 degrees in the numerator. So we're going to see that radians are going to cancel out, pi is going to cancel out, and we're going to be left with 180 degrees divided by 2, which is 90 degrees. And I think we already knew this angle measure, that a half pi is equivalent to 90 degrees. All right, so for example 2, we're looking at 2 radians. What is the degree measure for 2 radians? So if we think back to our unit circle and the way that we counted out the radius around the circle, I would probably guess that 2 radian or 2 radius counterclockwise would put me somewhere near maybe 120 degrees. But I want to find this out exactly. Okay, so we are going to take 2 radians and we are going to multiply by 180 degrees divided by pi radians. Because again, if we want to go to degrees, we should have degrees in the numerator. And we're going to see that our radians are going to cancel out. So 2 times 180 would be 360 degrees divided by pi. So that is the exact angle measure. So if I do 360 degrees divided by pi, that is approximately going to be 114.6 degrees. So I was close in saying that I thought it was going to be somewhere around 120 degrees. In our last example, we have negative 4 pi over 3 radians. Let's set this up. So negative 4 pi over 3. These are radians. Think about what you're going to multiply by here. If we're going 2 degrees, we want to have 180 degrees in the numerator. And pi radians is our denominator. So radians are going to cancel. Pi is going to cancel. We can do negative 4 times 180 and divide by 3. Or I can kind of help myself out here a little bit And I can do 180 divided by 3 because I know 18 divided by 3 is 6. So I'm going to divide that by 3 and get 1. Divide this by 3 and get 60. So I'm going to be multiplying -4 times 60, which would be a -240 degrees. Okay, so that's how we convert radians to degree measure. So the last part of our lesson is talking about the length of an intercepted arc. So we know if we went all the way around the circle, that would be the entire circumference of this circle. But when they're talking about the length of an intercepted arc, it is only this portion of the circumference. So to get our arc length, which they're calling S, we're going to use the formula S is equal to R theta. So let's define this. So S is the arc length. R is the radius. And theta is the central angle measured in radians. So if we needed to, we would have to convert degree measure to radians. If necessary. All right, so an example 4 says give the length of the given arc. So they want to know this distance from here all the way to here. So this red portion of the arc. So we know the radius is 6 inches and the central angle from the middle of the circle is 7 pi over 6 radians. So we're going to use our formula, S equal R theta, and our arc length is S. We know that our radius is 6 inches, and we are going to multiply that by the central angle, which is 7 pi over 6, and that is already in radian measure, so we are all set there. We don't need to convert. So we're multiplying by 7 pi over 6. We can multiply 6 times 7 pi and divide by 6, but ultimately 6 divided by 6 is going to cancel out. So we're going to be left with 7 pi inches over 1, or just 7 pi inches. That's the exact measurement of this arc. So if we wanted to know approximately how long this is, we would do 7 times pi in our calculator, and we would get approximately 22.0 inches. One more thing I want to say about this problem. If I gave you the arc length instead of the radius, would you be able to solve for that? So if I gave you the arc length was 22, you would substitute that in for S. You would substitute 7 pi over 6 in for your theta, and then you could solve by R by multiplying both sides by 6 over 7 pi. So S equals R theta. We may not always be solving for a missing arc length. In some problems, we may be solving for a missing radius or a missing central angle. But you can still use this relationship to solve. Example 5. A weather satellite in a circular orbit around Earth completes one orbit every 3 hours. The radius of the Earth is about 6,400 kilometers, and the satellite orbits 2,600 kilometers above the Earth's surface. How far does the satellite travel in 1 hour? Okay, so the first thing that we're going to look at is the center of the Earth, and what is the radius out to the weather satellite. So it says the radius of the Earth is 6,400 kilometers, and we're going to have to add in the fact that the satellite orbits 2,600 kilometers above the Earth's surface. So we're going to have to add that distance in as well. So together, our radius, 6,400 kilometers, plus the 2,600 kilometers, or kilometers, however you want to say that. So our radius is 9,000 kilometers. And the next thing we need to look at is, do we know the central angle? It says that the Earth completes one orbit every 3 hours. So it's going to take 3 hours to go all the way around this circle. And it is how far does the satellite travel in 1 hour? So that's going to be 1/3 of this arc. So to get theta, we're going to do 1/3 of 2 pi. So 1/3 of 2 pi would be 2 pi over 3. Another way to think about this is if you were going once around the circle that is 360 degrees, you're only doing 1/3 of that because it's 1 hour, not 3 hours. So if you divide by 3, that's 120 degrees. So we know that 120 degrees is equivalent to 2 pi over 3. So if we started off with 120 degrees, we would have to take that measure and convert it to radians. We would want degrees to cancel out. So we would have 180 degrees on the bottom and pi in our numerator. Degrees going to cancel out, so we're going to have what? 12 pi over 18. Sorry, if we divide by 6, that is going to give us 2 pi over 3. Because remember to use the arc length formula, because again we're looking for this distance that the satellite is going to travel from here all the way to here, we need to be in radian measure. So we know that S is r times theta. So in this case, our radius from the center of the Earth out to the satellite is 9,000 kilometers. And we're going to multiply that by our central angle. So our central angle is 2 pi over 3. Again, it has to be in radians. So if you came up with 120 degrees, you would have to convert to radians. Again, we can reduce. We have 9,000 divided by 3. We can reduce that by a factor of 3. So this is going to become 3,000 times 2 pi, which would be 6,000 pi kilometers, which is approximately 18,850 kilometers. That would be the distance that the satellite travels. So for this lesson, we are not going to be doing the bookwork as stated at the bottom of the notes. We're actually going to do some Khan Academy practice sets. Okay, guys, have a great weekend. Bye.